Hello, fabulous students. Today I want to talk about the derivatives of trigonometric functions. And we already know if f of x equals sine x, then f prime of x equals cosine x. We saw that graphically. So if we start with a sine graph, and we find our zero slopes. Let's change colors for that. Zero slope, zero slope. These are all negative slopes. Near zero, more negative, most negative, less negative, back to zero. So that's going to be like this. And here we have a little positive, more positive, and that's as positive as they get. And over here as well. So we know essentially graphically that these are that cosine is the derivative of sine. We also showed with f of x equals cosine x that we didn't get sine x for f prime, we got negative sine x. So if we think about this, we've got if f is sine, f prime is cosine, f double prime is the derivative of cosine, which is negative sine, and f triple prime is the derivative of negative sine, which is the derivative of sine with a negative in front. The derivative of sine is cosine. If I put a negative in front, I get negative cosine. And how about the fourth derivative? Well, the fourth derivative is the derivative of cosine. The derivative of cosine is negative sine times that negative out in front, and so we get back to sine. Okay, and we just cycle through all those options. Great. So next we need tangent and cotangent. So if y equals tan x, yeah, I don't know how to do that to it. But I do know that tangent is sine x over cosine x. So if I think about y as sine x over cosine x, and then I think about, well, I'd like to take the derivative of that with respect to x on both sides. So I take the derivative, and now I have dy dx on the left, and on the right, the derivative of this is going to be quotient rule. So low d high minus high d low. The derivative of cosine, remember, was negative sine, all over low squared. Well, look what we've got on top now. We've got cosine squared x plus sine squared x over cosine squared x. Don't cancel those out. What is this? What is cosine squared plus sine squared? Surely you remember your Pythagorean identities, and that's equal to 1. And 1 over cosine squared is secant squared. So, if y equals tangent x, y prime is secant squared x. Okay, so why don't you use that same technique to tell me what the derivative of cotangent x will be. Pause the video and give it a try. Well, welcome back. So we're looking for the derivative of cotangent. So I would say that's the same as cosine over sine. And if I wanted dy dx, I'd have to use the quotient rule over here, which now would be low d high minus high d low, all over low squared. Well, now, when I look at the top of this fraction, I have negative sine squared x minus cosine squared x over sine squared x. And you see these negatives? Well, I could factor them out. And now what do I have up top? I have 1 times negative 1. So I have negative 1 over sine squared, which is negative cosecant squared. So the derivative of tangent was secant squared. The derivative of cotangent is negative cosecant squared. Okay, so what's left? Well, how about y equals secant x? Let's take the derivative of secant x. So when I think about this, I think about, well, I don't know it, but I do know that secant is 1 over cosine. And then I think, well, I can take the derivative of this. I take the derivative with respect to x. Of y on this side, and 1 over cosine on this side. I'm going to find dy dx. And that's going to be quotient rule. Low d high minus high d low, all over low squared. Well, 0 times cosine makes that go away. And minus times minus is plus. So I have positive sine x over cosine squared x, which I choose to write like that. How come? Because this is tangent x, and this is secant x. So, what's the derivative of secant? The derivative of secant turns out to be y prime equals secant x tan x. You could certainly write tangent x, secant x, that's fine. But I would simplify it to this. So, can you tell me then what the derivative of cosecant would be? Do you have a hypothesis, by the way, about what it would be based on what we know so far? So, let's make a little table. Y prime. Sine was cosine. Cosine was negative sine. Tangent was secant squared. Cotangent, negative cosecant squared. Then we did secant, and that turned out to be secant tangent. And so now I'm asking you to figure out what cosecant's derivative would be. Okay? So use that same technique to find the derivative of cosecant. And think about these. Maybe you see a pattern. Okay, pause the video if you haven't already. Give it a try. For me, I see 1 over sine x. So if I take the derivative of both sides, I see that I have to use the quotient rule. So dy dx is going to be low d high minus high d low over low squared. Now 0 times sine x is going to make that go away. So I have on top negative cosine x, and on the bottom I've got sine x times sine x. Okay, what's that? Well, that's negative cotangent x, and what's that? That's cosecant x. So the derivative of cosecant is negative cosecant cotangent. Okay, and of course, you have to memorize this. Sorry, nothing to be done except you have to memorize them, okay? That's the page I'm looking for. So, let's look at some practice problems. For example, if I have y equals cosine squared x, I think a lot about, or I think we have a lot to think about with cosine squared, because we see cosine squared in our Pythagorean identity, sine squared plus cosine squared equals 1, but we also have that cosine squared power-reducing identity that we're going to meet next semester. Today, though, I have to think about cosine x times cosine x when I see cosine squared. So y prime is going to be product rule. This times the derivative of that. The derivative of cosine is minus sine, plus this times the derivative of that. And so we end up with negative 2 sine x cosine x. Ta-da! And that's y prime. Okay. So, what about this? Can we say something about y equals tangent squared x? Well, by following that same pattern of tangent x times tangent x, I see a product rule. And we know that the derivative is secant squared x. So, this times the derivative of that. Derivative of tangent is secant squared x plus this times the derivative of that. And so I end up with 2 tan x secant squared x. Now, you could, of course, remember your Pythagorean identities and say, oh, secant squared is equal to 1 plus tangent squared. And there would be some distributing. You'd have 2 tangent to the third x plus 2 tan x. So that's also y prime. I don't know which one is going to be better. I know if I'm solving an equation, I would prefer the one that's all in terms of one trig function. Okay. How about this one? Y equals secant x tangent x. What would y prime be? Pause the video, give it a try, come back when you want to check your answer or if you have some questions. So it's a product, so this times the derivative of that, plus this times the derivative of that. Do you remember the derivative of secant? It's secant tangent. So what do we have here? We've got secant to the third x plus tangent squared x secant x. Okay. I could take a secant out of both of them, and that'd give me secant squared plus tangent squared, but secant squared minus tangent squared is the identity, not secant squared plus tangent squared. So it can't really go anywhere with that. Okay, how about this one? Y equals x squared cosecant x. Well, again, this is a product rule. So y prime is going to be this times the derivative of that. The derivative of cosecant, we said, was negative cosecant cotangent plus this times the derivative of that. And again, I'm not really interested in simplifying this right now. In chapters 3 and 4, you don't have to worry about simplifying. However, some students actually do like to start to do the simplifying because they know that when they get to chapter 5, we're going to have to factor these and set these things equal to 0. And so if you don't practice or don't try it along the way, it's very uncomfortable by the time you get to chapter 5. However, alright, so I've talked myself into it. I can take out an x and a cosecant x, and I'm left with x, negative x, cotangent x, plus 2. It's factored, but yeah, I don't know how to deal with those. So, kind of a moot point. Alright, how about y equals 3x over tan x. So when we take the derivative, what do you see? That's right, I see a quotient. So this is the quotient rule. Pause the video and give that one a try. So with quotient rule, low d high minus I d low, the derivative of tangent, secant squared, all over low squared. Yeah, all I see to do is pull out that 3, so I'm moving on to the next one. How about y equals cotangent x over square root of x? Yes, I agree, that's going to be a quotient rule. But don't forget, you may want to rewrite square root of x as x to the 1/2. You could even consider it as x to the negative 1/2. And so you don't have to use quotient rule, you could use product rule. I generally prefer to use product rule myself. So let's take a look at this one. Actually, why don't you take a look at it? Cotangent x over x to the 1/2. So y prime would be low d high, derivative of cotangent is negative cosecant x squared x, minus high cotangent x d low, 1/2 x to the minus 1/2, all over low squared. So, you know, if I do some factoring here, I can take out a negative, and I can take out x to the smaller power, so negative x to the negative 1/2. And what am I left with? Well, when I factor negative 1/2 out there, I get just x cosecant squared x minus 1/2 cotangent x all over x to the 1/2 squared is going to be x. And you could simplify this and turn it into x to the 3/2 on the bottom. But that's about all I can do. I really wouldn't want to have to set that equal to 0 and try and solve on my own. Okay, so how about this one? Y equals sine x over x squared. Why don't you practice with that one? Okay, welcome back. We've got low d high minus I d low all over low squared. You know, if I know my basics, if I know what the trig derivatives are, know how to do the quotient rule or the product rule, these problems aren't so bad. So, for example, if I had, speaking of which, sine x over x squared is what we just did. What happens if we do sine x times x to the minus 2? Well, now it's a product rule. So this times the derivative of that. X to the, remember, subtract 1, negative 3, plus this times the derivative of that. Okay, so I could factor out an x to the negative 3, and I'm left with negative 2x plus x cosine x. Sorry, over here I meant negative 2 sine x. All right, so trig derivatives, not so bad, and do. How about our dear friend, write the equation of the tangent line to y equals tangent x. That's a bold move on my part. Yeah, at x equals pi over 4. Okay, so what information do you need in order to write the equation of the tangent line? You need a point and a slope. So we've got half a point here, pi over 4, but how do we find the other half? Well, if I take this x value and plug it in here, what is the tangent of pi over 4? Well, it's the same as sine of pi over 4 over cosine of pi over 4. So we have root 2 over 2 over root 2 over 2, which is 1. So there's our ordered pair. Now what about slope? Well, we remembered that slope and derivative are synonyms. So y prime, well, y prime for tangent is secant squared. And what I'm looking for is y prime at pi over 4, which is secant squared of pi over 4. Now, I'm not so comfortable with secant squared, but I am pretty comfortable with 1 over cosine squared pi over 4. What is the cosine of pi over 4? That's right, root 2 over 2. So I have 1 over root 2 over 2 squared, because this was cosine squared. That's going to be 1 over 2 over 4, which is 1 over a half, or 2. So our slope, or y prime of pi over 4, turns out to be 2. So then our tangent line equation, y equals, y minus 1 equals 2x minus pi over 4. Fabulous. Can you write the equation of the normal to y equals cotangent x at 3 pi over 4? Can you find that, please? Pause the video and give it a try now. So we need a point. We've got the x value. What about the y value? Cotangent of 3 pi over 4 is cosine 3 pi over 4 over sine 3 pi over 4. Well, cosine is negative root 2 over 2, and sine is positive root 2 over 2, and so I get negative 1. Now, what about the derivative? Well, we know that the derivative of cotangent is negative cosecant squared, and I want y prime of 3 pi over 4. I need the slope at that point. And so that's going to be equals negative 1 over sine 3 pi over 4 squared. The sine of 3 pi over 4 is root 2 over 2. So I have negative 1 over root 2 over 2 squared, which turns out to be negative 2. Right, because this is that same process we had for tangent, where we're going to get 2 over 4, and then we flip, and then we end up with 2, but ours has a negative in front. So now I know the slope at 3 pi over 4 is negative 2, and writing the equation of the normal slope is positive 1/2, right? We want opposite and we want reciprocal. So y minus a minus 1 equals 2, no, equals 1/2 x minus 3 pi over 4. And you can certainly stop there, or you can tidy this up further. We have 1/2 x minus 3 pi over 8 minus 1. See that? Why do that? Just leave it like that. Alright, so that's it. That's the last of the new material before we take our test. I'm hoping that you will study more than just your shortcuts, but remember, you need to really pay attention to your limit definitions of the derivative, okay? All right, I'll see you in our next review video. Take care, everyone.